Greetings everyone, and welcome to this video on the Vovk-Sellke Maximum P ratio. The concept of the Vovk-Sellke Maximum P ratio, or VSMPR in short, was introduced by Vovk in 1993 and furthered by Sellke, Bayari and Berger in their paper in 2001. The VSMPR takes into consideration the p-value obtained and tells us how likely it is that this p-value falls under the alternative hypothesis over the null hypothesis. All p-values are not created equal. The VSMPR represents the maximum odds that the alternative hypothesis is favored over the null hypothesis. This might be better illustrated with the help of an example. This dataset provides us with the reading scores of two groups of students. One who were treated with reading activities before the test and one who served it as controls. We will test the adequacy of the null hypothesis that the reading activities given do not influence the scores. We will perform an independent samples tree test to assess the null hypothesis. We will also check for normality and equality of variances. There seems to be no problem here. So we have gotten a p-value of 0.029, which suggests that we reject the null hypothesis and accept the alternative hypothesis. We can just get some descriptives and we can see that the treatment group actually did perform 10 points better than the control group, which was significant. So what is the diagnosticity of this p-value? What is the diagnosticity of this 0.029? To check for that, we will use the VSMPR by selecting this checkbox. So we get a VSMPR magnitude of 3.616, that is the maximum odds that the alternative hypothesis occurs over the null hypothesis is 3.6 times, approximately 3.6 times. So the VSMPR is a test for the diagnosticity of the p-value. Suppose we get a p-value of 0.5. We need to be sure that our claim, which rejects the null hypothesis, is fairly strongly accurate. In short, we need to be quite sure of the diagnosticity of the p-value which we get to make a strong claim. And the VSMPR helps us to do just that. The VSMPR can be considered a classical alternative to the Bayes factor in Bayesian analysis, just a rough analogy. So that's it for this video. Thanks for watching and I'll see you in the next video.